Hello everybody, we're going to do a little bit more factoring, a little bit more advanced steps for our trinomial factoring. Um, so we are given 3x squared plus 9x plus 6. Our first step in factoring trinomials or really any problem we should look for, is there something I can take out that would help? Is there a common factor between terms? So if I look at this problem, I see 3x squared plus 3 times 3x plus 3 times 2. So what happened was I recognized that 3, 9, and 6 all share a common factor of 3. So what I'm going to do is I'm going to go ahead and I'm going to pull that 3 out in front. So what I just did was I factored out a common factor. Well, the greatest common factor for that matter. And then we would go ahead and factor this normally, which is our basic factoring trinomials. The previous video, the previous section of your course, is how we would do this. And I'll just quickly go ahead and say this is going to be x plus 2, x plus 1. Now, it can be more than just a number. If I look at this problem, if I want to really expand this out, this is 7 times x times x minus 7 times 6 times x plus 7 times 8 times x. And then if I go over here, sorry, I'm going to lose my spot here, is they share a 7 and an x. So it's more than just a number this time. So I am able to factor out variables just as much as I am numbers. So this is 7x out in front, and then we'd have x squared minus 6x plus 8. And again, this is now a traditional trinomial factoring. So I'll just do it, and those steps are on the previous video that you guys were able to look at. What's this going to be? There we go. And then the last piece here is this. Now there's no number in front, right? We just see it. There's no number. It's just kind of negative x squared. Well, that negative is a -1, and we always want our leading coefficient to be positive. We need it to be a quadratic, so it needs to be a square term, and we need it to be positive. So what I'm simply going to do here is I'm going to factor out a -1. And when I factor out a -1, all I'm doing is changing the signs for all the terms. So this was a negative, became a positive, this was a negative, became a positive, this was a positive, became a negative. And then this is again traditional factoring. That -1 stays out in front. Notice the greatest common factor each and every time has stayed out in front. And then that allows us to go ahead and factor this. There we go. I believe that's right. Should be right. Now, for my Apex students on Algebra II Semester 1, this is 3.2 study, and it's on page 10 of the actual online study. These are the example problems from there. Bridge math, I would suspect is 4.2 and still page 10, maybe a little bit off, but I do believe that they're going to be pretty consistent. I will be using my normal factoring steps at some point. It's this page. If you don't have it, let me know. And then for this stuff, we're going to be using our AC factoring stuff, which is this page. And we are specifically going to use the first example. The second example is an error in there, I believe. So we're just going to focus on the first example here. So my first step of my AC method. Okay, so I guess let's look at, we have 6x squared plus 13x plus 5. So our leading coefficient is not 1. It's positive, but it's not 1. And there is no common factor between 6, 13, and 5 other than 1. So factoring out 1 doesn't help us. So what we will do is go through my AC steps. So we have our starting trinomial, which we do. The first step, ooh, I lost mine, there we go, is we're going to multiply A times C. Well, my A is 6 times 5. And what we're going to do is we're going to set a new trinomial. I'm going to make my A term 1. So I eliminated the 6, made it a 1. My B term stays the same. And now, instead of a 5, I'm going to take that 30 I just got. So now what we have is we have a more traditional trinomial, a more basic trinomial that to work with. So, and we'd be able to factor this. We have those previous factor steps. That's that basic factoring. So we could go through these, and what we would end up getting after we factored would be x plus, ooh, this is going to be, oh goodness, brain fart there. Wasn't prepared. It's x plus 10, x plus 3. Excellent. See, even math teachers need to write it down so they can remember. Doing it in my head, I delayed. So we have x plus 10, x plus 3. Now going back to those AC method steps, what we just did was factor the new trinomial. We did that. Now we want to put the original A value, which was 6, back in front of each term. So I'm going to put a 6 there and a 6 there. So I will go ahead and write this a little bit more clean. Oh yeah, I won't exactly call that clean, I guess. You get a bigger little drawing tablet here. Excellent. So now, the next step says take out any GCF. So we're looking at these individual. All right, so individually, we're going to look at this, and then we'll look at this. Is there a greatest common factor between 6 and 10? There is. It is going to be a 2. So I'm going to take a 2 out. And this is going to be a 3x plus 5. And then for this one, 6 and 3, my greatest common factor is a 3. And then what the last step says is you throw away this GCF space. I'm just going to cross it out. And my final answer is going to be 3x plus 5, 2x plus 1. So we had to kind of manipulate it a little bit, but I followed those AC steps, and it got me there. We don't want to do it Apex's way. Apex basically is teaching a guess and check method, and we just don't want to do that. This next box problem, again, 9x squared minus 3x minus 20. There is no common factor between all three, between 9, 3, and 20. So we'll have to follow our AC steps. We have a trinomial. We are now going to multiply A times C. So we have A times negative 20. And that's going to be negative 180. Now we're going to make a new trinomial. And now I need to factor this. So I did not do this ahead of time, so I'm all kind of spitballing here, so I'm going to have to look at this. Shouldn't be too bad, huh? 18 and 10, so something smaller than that. So it's going to be 12 and 15. Again, this is our basic factoring steps that we covered in the previous video, and then you have access to. Obviously, I can link you to that if you need it. Then we're going to put the original A value back in, which is 9. Now I'm going to kind of skip a step here. What's the greatest common factor between 9 and 12? Well, that's going to be 3. And what's the greatest common factor between 9 and 15? Well, that's also going to be 3. And this is, again, as we saw in the previous problem, the greatest common factors usually are not the same. In this case, they are. That's okay. But it's not normally that way. Cross off my greatest common factors, and then I can just write my final answer. 3x plus 4. 3x minus 5. That's my final answer. Those are the steps.